Okay, I won't keep you waiting any longer. I'll just start. If people join, that's fine. So welcome to this webinar about data analysis concepts. As I will explain, we'll be looking at very basic concepts, some statistics and counting, computed fields, grouping information, looking for duplicates, visuals and filters. And the point is to give you some concepts, but the 1 hour that we have allotted to this webinar is insufficient to go into a lot of depth, a lot of detail. So basically, it could be more of a teaser or an eye opener for some, and I'm always available afterwards if there are additional questions. So without further ado, let's start, and I'll start by introducing myself. My name is Alain Rousseau. Basically, I'm passionate about data analysis and about GRC tools in general. What I love most in those type of projects is either doing training, so training new users, or implementing the projects. And that is why in 2010, I started Sepia Solutions to focus on exactly that type of software. And well, we boast that we have the technical skills to implement such projects from A to Z. Over the years, I've worked together with the IIA Belgium quite a lot as a sponsor, cooperating with events such as the Audit Software Day, which is usually a biannual event. Maybe one thing, if you're not connected on LinkedIn, I'm there, and you can either get to that QR code that will direct you to my LinkedIn profile. It's always nice to keep connected. All right. This is the first webinar in a series, not a series of 4 or 5. I do intend to continue doing webinars like this. At the moment, I'd like to organize one such event per quarter, approximately, but we'll see how it goes. So the tool I will be using to do this webinar on, and the future ones as well, is from Arbutus. There are other tools in the market, for sure. There are other tools that basically do a lot of the same things. What I would like to mention is that not all tools used for data analysis are as good for their purpose. I mean, they're all very good tools, whichever tools you use, including spreadsheets, for example, including Power BI. I like both of them, to name just a few, but it is my opinion that they are not created to do specifically data analysis. For other things, absolutely, but not exactly or only for data analysis. Arbutus, on the other hand, is purposely built for data analysis. That's the only thing it does. It supports features like having no data size limit. So whether you have 200 records, 2,000 or 2 million records or more, it shouldn't pose a problem. It furthermore accesses the data always in a read-only mode. And of all the, I think, about 80 commands that we have, everything you do is typically already logged automatically in the audit trail. So those are a few of the features that are very much in favor of doing something like data analysis or audits or internal controls with a tool like this. To give you a broader scope, what the webinar will use today is just the desktop client. So the interface sitting on your desktop. In the architecture, there are more components, such as the data connectors there at the top, the hub, which is a central server to either share resources or centrally manage those resources and automate tests. So if you have, let's say, a control that you need to perform every Sunday at 2 in the morning, that would typically be scheduled on the hub. As important, I find, as the software is the support, and that's basically this lower side, lower part of the screen of the graph is the ecosystem and supporting resources. So apart from the software, we can always supply online training or on-site training. There's also a very good self-learning portal. There's technical support. There are plenty of use cases. There are fora. there are webinars and other events and user groups to help those people, those users, with their queries, with their projects. What data do we use? And that's always a very big problem I find in any type of illustration, demo, or training. What data can I use? I can't use the data of our clients, of course, they're confidential. I can use training data, but typically training data is a small number of records. So that poses us a problem. I'll be using a data source which is available to us all directly. It has more than 500,000 records, but it might not be the data that you are accustomed to. We'll see about that. I look at how we access the data, what the table layout is, what records and fields are, and then demonstrate simple statistics such as count, total, and statistics. I'll illustrate filter features, and both classify and summarize are two ways to group data together based on a common factor. There'll be some duplicates testing in here as well. Very briefly show some visualizations. And in the end, even though we have a very strange data set that I'm sure you'll never use, I hope to come to some business insights that we can actually convert the data to information and even some business action. And I'll close with illustrating some automation as well. If any of you would like to try this out yourself, that's absolutely great. Just let us know. You can request a trial license for this software so you can play around with it yourself and see whether you can replicate the things I do today. Okay, so that's just a slide to bring me to the desktop. All right, so here we should have the Arbutus Analyzer desktop screen. If you don't see that, please let me know in the chat. So at the top, like any Windows applications, we have the menu, a toolbar. On the left, we have what we call the project overview, so all the components within our project, i.e. at the moment, none at all. And here the largest part of the screen is the display area, which currently features only the command log. As I said, the first thing we need to do is we need to access data, and we can access CSV files, text files, Excel, Access, ODB sources, and many others. But I would like to start with one that we just can create out of thin air, as it were. And if you allow me, I'll just type the command and I'll explain it as we go along. I'll explain the details once it's started. I've got time then. Not drive. Now that it's started, I can explain. So this command, directory, is listing all the files and all the folders in what we now defined as C Windows, so the Windows part of our drive, asterisk.asterisk as a wildcard, so it's listing all the files and all directories within the Windows part of the system. Is traversing all the subdirectories in it, and it will then create a table we call drive_C_Windows. That's what it does. And the command itself is more than basic. We don't even cover this normally in the initial training, but it's just a way to create a lot of directories, sorry, a lot of records. As you can see, it's already created 400,000, and I'm expecting more than 500,000 records. Why? Because it's a good example of a, let's say, fairly large data table. It also contains all the types of fields we would normally encounter. It will have text fields or character fields. It will have numeric fields, such as file size, and it will have date fields, so when the file was created, edited, or accessed. So here we have it. This is the table that this directory command has just created. I'll just open it up. There we are. So here we have the what we would normally call, let's say, columns, but the fields such as file name, file size, attributes, modify date, access date, and create date. These are the nice aliases. The actual technical labels, if I just drag it up, is slightly different. It's file underscore name. That's the real technical label for that field. Yeah. If we look at the source and the location, we can go to the table layout, and we can see that each record, and each record is what you would normally define as a row typically, consists of these fields. So the file name, the file size, file attributes, write date, access date, and create date. We can see that the last three have the letter D in the category, so those are date fields. Name and attributes have character C for text or character, and the file size is numeric. And if you just double click on that, we see that the field file name, defined in UTF-16, so that's Unicode, covers this part of the actual data source. The data source itself, let me just close this, yeah, is defined here. So each record is about 2,000 characters in length. So those are really the technical details. It's just looking at the data, and this table layout is the metadata, which defines the actual data underneath. How many records do we have to start with? And again, I doubt very much that you will ever look at your file system this way, but I am approaching this as I would do a lot of tables that I don't know in a type of exploration. So first of all, I would count the number of records in that table, and that command count, as you can see here, it's written down into the log as is the result, which is 500,000 or 538,045 records. That means files and or directories. We have a file size. Some are 0, others are larger. So we can just see what is the total file size of all these files and directories together. So we will total that up with the total command. And this is in bytes. So we would have to see if this is in bytes, then we got kilobytes, megabytes, gigabytes. So on my disk, there's about almost 45 gigabytes of files and directories just in my Windows drive. Okay, and I'm pretty sure on your system it'd be approximately the same. One other thing is we could run, for example, a statistics, again, on the file size to get an idea. A statistics gives you a very quick idea of the underlying data, i.e. it says that 351,000 and so on are positive file sizes. Of course, I don't think you can have a negative file size unless there's something seriously wrong with your file system. We have a lot of zeros, which in this case would mean it's either a directory or a file with really size 0. And just expand this and think we're not looking at files, but you might be looking at either financial transactions, log files, just recorded weights of a weighting system of trucks, invoices, whatever the data source is. You could look at this numeric field and see how many positive numbers, how many zeros, and also how many negatives. Yeah, and it gives you a rough idea of what you're talking about. Also, the lowest size, the smallest size in this case is 0 bytes. That makes sense. And the largest is just under 3 gigabytes. All right. We can see here that we have attributes. The D is to signify that we're talking about a directory, and we have other files attributes that you can look up at your leisure. The D would signify it's a directory, so let's try to find out how many directories we have. I could right-click and say quick filter equal to find all the records that match D as a value, but that would negate things like here that we have other attributes as well besides the D. So I will be looking to create a filter that says just look for the letter D in the file attributes wherever it is. And for that, I'll just create a filter here with what we call the expression builder. And there is the list of functions, 100, 110, 120, don't recall exactly. And one of them is a logical function to find information. So I'll be finding or looking for the letter D in the file attributes. Okay. And this then executes, it sets a filter, and if I then count, I can see how much directories I have. Here in the log file, you can see we're setting different filters, so the commands are logged. This is the most recent filter I've set, where we look for the letter D in the file attributes. And if we count, we have 186,867 such directories. We can see here that we have slightly more zero size records, which means there are really some files, not directories, but files with size 0, apparently. Okay, I can just clear out the filter right there. Let's have a look at the write date as well. So that's this modified date, the write date. Also on a date field, I can do some statistics just to have a look. And we can see quite a lot are, a date in the weekend, fair enough. But what interests me the most in this case is the most recent file in my file system. It's just 23 minutes ago. So some file in my file system was modified just very, very recently. But the lowest, i.e. the oldest files apparently in my Windows file system, and this is not fake, this is real, is from June 1998. Now, whether that file really dates from 1998 or whether the file attributes simply states that it does, I don't know. I would have to look into that. But this is weird. This is for me kind of an anomaly in this data set. And you can do such simple statistics on any such data set to get an idea. Now, does anyone know when YouTube started? So the popular social kind of video sharing platform YouTube. Any idea? Anyone? Well, it's February 14th, 2005. So let's just see if we have files that predate the existence of that platform. So we could go to the filter and say our write date must be less than, so it's older than, and we'll put in the date. So that will be 2005. It's quite a long time ago. February 14th. Okay. So it's now scrolling through those 500,000 records. We found a few. How many did we find? Let's just see. So 32. We have 32 files that predate YouTube. A lot of people won't even remember a time before YouTube. Okay. What else? So these are filters. We're just exploring the data, but I find it difficult to look at the file size in bytes and calculate in bytes. A lot of files will have a very huge, very large size. You could say file size would be an amount value on a lot of other data sets. So what I want to do is I want to convert this file size in bytes to file size in megabytes, as in you would have a currency exchange, for example, an exchange rate. So I'm going to create a new field, but not a new data field, as we're not touching the data. I am going to create with the table layout an expression, a computed field. I love computed fields. And I'm going to create a computed field. I'll call it C underscore, just a file. C underscore is basically in convention, a naming convention to indicate it's a computed field. You don't have to do that, it's just easy. So file size MB for megabyte. And I'll make it a nicer title as well. I'll call it file size megabyte, like that. And the value for that, I can either type it or I could use the expression builder again and say I'm looking at file size divided by, and now it depends on what standard you'd like to use, either divide by 1,000,000 or divide by, oops, sorry, I was wrong. So file size divided by this. Yeah, so 1024 times 1024. I'm not sure which standards is now the best one to use, to be frank, but file size has been defined in this table as having 0 decimal places. So it's an integer number. And if I'm going to divide it by 1,000,000, I'm going to lose a lot of granularity. So before I do that calculation, I'm going to convert the file size that we have to define it as, let's call it file size. Yeah, sorry, I was going to say Control V, but file size, yeah, with 6 decimals. So I'm going to convert it to a more precise number and only then doing that division. All right, so there we go. This is our new computed field. It is added to the table layout. It is not added to the data file itself. I can just add that new column there to the view. And then we have our file size in megabytes, which makes more sense nowadays. And if I total that up, it'll take a second or two. All right, it's all already a lot easier to see, but I can also see that I still have my filter on. As you can see, it's a kind of a warning that, oh, hang on, you're just looking at the 32 files, which are very old. So let me do that again. I'm going to clear the filter. Total file size up in the megabytes. And now I have 42,515, to i.e. 42 gigabytes. And again, you won't do this on file sizes, I'm pretty sure, not in this case, but you might be doing it on exchange rates, on valuta, on currencies. Okay, what else can we do with a data set like this? We can look for the file name or directory name, because what we currently have is sometimes a very long name here of files that are in a directory, in a directory, in a directory, in a directory. And maybe I just want to see the last part, so the actual file name itself. And we can use text formulas for that, text manipulation. And I'll go back to the table layout, and I'm going to create another computed field. I'll call it file name, simple. And how are we going to compute it? Well, we'll be looking at the file name, but we'll be looking at the last part. So the last part after the last, let's say, backslash. And for that, we're going to use another text transformation called split. And split will help you get that part of a string or text field that you name. So it's file name that you're looking for. The separator in this case, in terms of directories, is a backslash. And I want not the first, not the second, not the third, but the last part. And that's so looking for the right-hand side, that's negative. So the -1, meaning the very last. Yeah. But I don't just want to use file name. I want to have the file names in all lowercase. So I'll just wait for that, and I'll just do a lower first. So I'm going to nest these functions within themselves. So I'm going to go for the lowercase of file name, and then use the split. And finally, Arbutus will use the same length, technically or theoretically the same length as file name, because it can't know anywhere else or any other value. But I want to shorten it, because now I think the length was about 2,000 characters, which is way too much for just a file name. And I've tested this, so I'll just have to believe me that 400 is enough. I'll take the first 400 characters, 400 i.e. in Unicode, so it might actually come down to 200 real text fields. So this should be it. Let's just see if I got this right. Apparently I do, at least in the syntax. And we'll call this what? File name. Simple. So, and let's see if that does what I expect it does. So I'm just making this a bit smaller again and adding another field to the view. Right, so we can see it indeed got the last part after that last backslash. Let's just find a bit further down, let's say more complex stuff. So here we have indeed a PNG, a graphic file. Yeah, and it's taking up the last part. So that works. So I'm able to extract text, extract data the way I want it to be. Another thing that I find interesting in this case is how many levels down do those files exist? How many subdirectories basically do I have in my Windows file system? And just an extrapolation, you might want to do this type of thing on other data. So how many occurrences basically do I have of this backslash? That's the question. How many occurrences do I have? And that would signify the depth of directories. And if I would consider C:\Windows as my first one, I don't want to count this one because that's my starting point. So I will count the number of backslashes and detract 1 from that formula. There we go again. Creating a computed field, not a data field. I'll call this directory depth. A nicer name. Like so. Again, I'll use the expression builder. I believe it's also a text function, the occurs. Yeah. So within file name, we are looking for the backslash in quotes as we're looking for text. And from all of that, I want to detract 1 because C:\Windows was my first level, basically my starting point. So I won't use that one. Okay. Great. And adding that to the view, directory depth. There we are. So 1, 1, 1. Let me see with the statistics how many I have. So lowest is of course 1, but the highest is 12. So I could click on these values to actually set the filter directory depth equals 12. And these are the, let's say, most deeply stored files within 12 levels of subdirectories, if you'd like it to. Let's take a simpler example like 5 to see whether we did the calculations correctly. Right. So here the Adobe db.dll. Yeah, so that would be level 1, level 2, level 3, level 4, level 5. So indeed, that makes sense. So I'm happy with that. I'm happy with that. I like computed fields, and what I like even more than a simple computed field is a conditional computed field. It's a what if type of statement, or if you know other languages, you could compare it to a switch or a case statement. I like those very much. And it helps us to add logic, business logic, or just ways to help us as a human interpret the information. Once again, if I would be looking for the attributes, like I did at the start of this webinar, looking for the letter D in file attributes, that works technically, that's absolutely fine. And then if that is true, I know that we're talking about a directory, but I find it difficult to discuss it like that. So what I'm going to do is I'll use that same logic, but add a layer of interpretation to it. So I'm going to create another computed field via the table layout. I'll create the field C, just type, a computed type, like so. The default value, let's say I'm looking for files usually. I'll encounter files usually. I'll call it file type, I think, record type. But if the default value is file, that means that I need to insert a condition to say in other cases, it's not a file, but a directory. When? Well, if, and we know the condition, if we find the letter D in our file attributes, then it's a directory. So then it will display directory as the result of that field. And then I can add that to the view as well. Type There we are. And I find that far easier to show people, to discuss with people, what are we talking about. Maybe one or two more files like, or fields like that. We could be looking at the year. When was this file created? And we can do that via another computed field. That's the last one I create, I promise. So see, right here, when was the file created? And I want this to be a text, but first we need to extract the year from the date. So that is the year, simple called function year, to extract the year from the right date. But then I want to write this out as zones, meaning convert it to a text field like that. Right here, there we are. Okay, and then we can filter and do analysis on that. What we can do, for example, both on right year and a record type is, for example, we can group this together. So we could classify that based on either directory or files. So let's classify that. And let's just create a graph out of it, do some visualizations. There we are. So on the left, we have the directories and the number of records that match that type. And here we have files and the number of directories that match that type. Or if you'd like that as a pie chart, that's fine. We can do it as a pie chart. In these charts, if you click on that, it will take you back to the table and set this type. So set a filter and you can continue the analysis. The same would be true for the year. So if you would classify and group information on the year and think of it as doing it per vendor, per client, per business branch, or something like that, that will work. And if we group it by year, we could, for example, summarize, so add all the file sizes together and have a look at it. And let's see. So in a bar chart, this is the result of that in a bar chart. And most files, in terms of size at least, are, let's say, very recent this year or last year. But we can see there are actually years in the past, and it kind of surprises me in this type of data set. Yeah. Let's just go back there. Okay. So what we've done, we've created some filters to explore the data. We've did count and total statistics. We created computed fields to extract data that we're interested in. We've added conditional computed fields as well. And we can carry on creating computed fields like extracting the file extension, for example, to see how many files of each extension type that we have. I think I'm going to leave that in light of the time that we have. I would like to demonstrate another type of command to group data together, which is even more powerful than this classify that I just mentioned, and that's the summarize. Summarize allows us to do a lot more with the data itself. Suppose I want to summarize indeed based on the right year. So it's like the classify, but I'm doing it on the year now. And then we can process a lot of data fields. What do I want to do? I want to see, for example, the size, and I can look for all the fields with size in, and I can add that multiple times. So I can compute the sum of the file sizes. That could also include the average, for example, of the file sizes. I'll just give it another name. I could even do something, as you can see, standard deviation, minimum, maximum, first, last, standard deviation, to get some idea. And I often use this command in very many analyses. It's very powerful. And we're going to write that out to a temporary table, summarize right year, like that. Okay, there we go. It will take a bit because it's first preparing the data file, so sorting the file, then computing, I want to save changes, computing all the output, and here we are. So here we have, for all the years, the number of records we have, and the total size, average size, and standard deviation of those files. And here we can see with this kind of blue icon, a down arrow, that it's derived from our main table. And I could go in and say, click here to get back to that table and look at all the files written or created in 2009. So that's kind of the interaction between the result table and the source table. Okay, so I'm going to go back to our source table here, closing everything. There we go. Let's look at duplicates. Now we could look at duplicates here, file name, for example. Of course, we can't have a duplicate here. Windows won't allow you to create the same file in the same directory with the same name. It can't happen. But we could look for duplicates of the files in the file system. So let's do that. If you go duplicates, looking for the simple file name. We might want to add the full file name so that we know where it came from, the full path, as it were. And I kind of expect a lot, so I'm going to go to data, temp, duplicates, based on the single field. Yeah. So it's now looking at the table, pre-sorting the table, and this is why I took a reasonable data file. It illustrates it more than in a fraction of a second. There is some thinking to do here, but here are all the duplicates. Yeah. So the file 000 exists, for example, in a lot of different directories, or it could actually be a directory itself. Yeah. And we can analyze that, and just to make sure how many that type of duplicates we have, it's 400,000 and so on. So it's a lot, but it's also not a true duplicates test, not yet. Because a file called temp.txt might exist dozens of times, I don't know. But let's see if we can find real duplicates. So duplicates that we think are probably a real duplicate, where it's the same file name, simple file name, the same size, and the same write date, access date, and create date. So if all of those parameters are really all the same, I think it's fair to say that we're likely looking at a duplicate. To make it absolutely sure, we should still do like a hash of the file itself, but just for now, let's consider this like you would do in a duplicates payments test. You get this anomalies out, or this result set, and then you go back to look at the source of the data, the actual invoices, to see whether they're real duplicates or just a suspected duplicate. So let's start on the duplicates, but then now in full. So I want the duplicates on the simple file name, on the file size in megabytes, and on all the date fields. So that will be the write date, access date, create date. So if all of those are the same, then I consider this file a real duplicate. I then want to maybe list the full file name so I can find them back to original file, and maybe the file size and attributes, just by way of information. And I want to go to a data table, temp, duplicates. Let's go. Again, it will take a few seconds. That's absolutely fine. It's just illustrating we're processing a lot of data. Okay, so here we have the whole duplicates test. We have less now. If you count the number of records, it was about 400,000 before. It's now just 173,000. Again, you won't do that on file sizes and so on. You'll do that on transactions, invoices, log files, what have you. So here we have it. What would be the total size, the total cost, as it were, cost in disk space of those duplicates? Well, it says here 5.8 gigabytes. But it's not that if you would clean up all the duplicates, that this is the file size we could save. That is not true, because then we would also delete the, let's say, original one, which we must keep. Yeah. So if we would expand on this, we could say, look, I want to calculate now what the total size is that is being used by these file types file names, but I also want to know what the file size is of the one unique file that I must keep, for example. And to do that, we're going to summarize it again. This results table, we're going to summarize based on the file name simple. And we are going to compute the file size in megabytes. So the sum to let us know in total, all these duplicates use up this much space. And I want to see the minimum, but whether it's the minimum, the first, the last doesn't matter because it's all duplicates, so it's going to be the same anyway. I'm just going to say for a single file, this is how much disk space I would use. And we're going to do that to another temp table or result table, if you like, potential savings. There we are. I hope I did it right. Let's just see if I sort it. I've got data. That's good. So here we have an example where I have a few duplicates and just 2 of those. In total, I use 139 megabytes, and I should use only 69 gigabytes, for example. Now I could add a column here, a new field as an expression, just call it savings, potential savings. And say it's the sum minus the one I must keep to keep a full data set. And this is what I could potentially save in cost, in disk space, in whatever inventory. And that would come down to, let's see, 3.9 gigabyte. So that would be the end conclusion, if you like, of this type of analysis. We're looking at transactions, we're looking at costs, inventory, warehouse data, whatever it is, and we find that we store the same item multiple times. So if you look at the cost of that item and look at the one item, how much that costs, how much it weighs, whatever the data is, how much disk space it uses, and we remove all the redundancy, we could potentially save up to 3.9, in this case, gigabytes. And if we would calculate that, that would be how much? Let's see the full set again to calculate this. So initially, the total for the disk, file size in megabytes was 42 gigabyte. And if I would do the calculation, is it 3.9? Yeah, 15 divided by 42. About 9%. So that's basically converting all of that test to, let's say, some conclusion here in the end. I don't think I'll save a lot of money if I would delete those files from my file system. I don't think it'd be a good idea anyway to do that without Windows knowing. It's just an illustration of turning data into information. And if you come to your manager or to the board or the audit committee or the auditee, whoever, with a plan to save a couple of percentages, 5%, 2%, 7%, and a total amount, let's say, you're coming with a good suggestion. And I think that's one of the differences between the data and the business information afterwards. Okay. Finally, if I need to do that again next month or next year, I could do this all again, or in this case, next webinar. Yeah? I could do this all again, or I could store these commands, store these commands somewhere, and basically store them centrally. I could share them, as I have done here, in the apps. This is basically the demo. I've stored all of that in this demonstration, and I could just run that again. It runs through all the similar tests rather more quickly than I now do while explaining everything. And I don't need to think about it anymore because it just then does it automatically. This is what we've done, one of the last things, I believe. Okay, it's now going to do the sorting for the summary and so on. And basically, it will speed up the analysis and perform that complete analysis and present us the conclusion. So this is basically what I wanted to illustrate to you, let's say not much interactively, but at least live. And let's see, so just in summary again, we looked at the access of the data, we looked at new data set, we defined what the record is, what fields are, we created new computed fields. I did some very basic statistics, as in count total statistics, so we did some filtering, then grouped data together with classify, summarize, and looked at the potential duplicates. And just very briefly also looked at the visualizations and what information we could gather out of that. And just at the end there, with the automation, and this is basically what the next webinar is about, is expanding the list of apps that you might create yourself, create your own type of toolbox, as it were, to work with your data, to look for things in your processes. Because there's one, let's say, section here that's already included in this application anyway. So if you would install Analyzer, you get these Arbutus Smart Apps in there automatically, and they cover, let's say, typical tests in accounts payable, receivable, and so on. So those are in there automatically, but the next webinar, we'll be looking at how to expand this data set or this toolbox yourself. Okay. At the moment, before we close, I would like to see if anyone has any question. We have a few minutes, so I can answer a couple of questions. If not, I thank you. I hope to see you again in the next webinar. But most importantly, if you have questions, suggestions or queries, if you have new topics you would like to see in the next webinar, I'm always looking for topics and subjects. So that would be great. Please let me know your suggestions. Okay. I've got one question here. How can I find for more than one information? I think, and thank you for the feedback, by the way. I think the question is, how can I combine data from two different tables, two or more? You're absolutely right. I didn't cover that at all. You're right about that, basically because of time. And we can bring in more tables. We can join the tables together. We can relate tables together. And maybe that's a very good topic for later. I'm thinking about two-way matching, three-way matching. So maybe that's a good topic for another webinar. How can I find out? And typically a two-way match is like, I've ordered this, I've got an invoice for that, I've paid this, does it all match? So that's a good topic for another time, but we won't have time for that today. If you want to know more about the joining or relating of tables together, please reach out via email or phone, and then we can cover that on a one-to-one, basically. The find multi, that's what you mean. So looking for multiple, we call it list find. So if you're just looking for multiple pieces of text within the one table, it's a list find. So we can add many different characters together or text fields. Okay, so thank you so much for your feedback. And really, I do hope to see you all again in one of our next webinars. This is a new initiative, and I hope we can carry it on. Thank you.